All right, in this video, we're going to talk about absolute values, both with equations and inequalities. I know absolute value is sometimes a confusing thing. Remember, what absolute value means is whatever you put inside an absolute value, the absolute value is going to turn it to a positive number. Um, so let's start with something simple. If I say I'm looking for numbers where I can take the absolute value of x and get it equal to 7, there's two numbers that would work. X could be 7 because the absolute value of 7 would just be 7, or X could be -7. And that's because, okay, so let's write this down. So if I have the absolute value of a positive number, that's just equal itself. But if I have the absolute value of a negative number, it's going to make it positive. It's going to become +7. In other words, it's going to become the negative of -7, which is +7. Okay. More about that later. Actually, this idea is kind of important. Um, but that's generally how we'll solve equations. And we can build off this because you can probably see from the next example, it's not just the absolute value of x equals 4. I've got the absolute value of some stuff. And so we could sort of generalize here that if I've got the absolute value of stuff equals some number, then there's always going to be two possible answers. Either my stuff just equals that number, or the stuff inside could equal the negative of that number. Again, assuming that this has to be a positive number. Let's make a note of that. This must be positive. Otherwise, the absolute value of some stuff couldn't equal that. But yeah, that's kind of a template for how we can approach these absolute value equations when things get a little more difficult. So, for example, here, absolute value of 3x minus 5 equals 4. 3x minus 5 is what I'm calling stuff, right? So the two possibilities, one of them is that 3x minus 5 could just literally equal 4, or what's inside here. The way I think of it is if I covered that up, -4, the absolute value of -4 would equal 4. So the stuff in the inside could also equal -4. And then I get two equations, and I'm going to solve them. So I'll add the 5 over here. 3x is equal to 1. X is equal to 1/3. Here I'll add the 5. I get 3x is equal to 9. Divide by 3. X is equal to 3. So those are the two numbers that would work. Okay, I've got absolute value of some stuff. But then, of course, what you would want to do before you try to get rid of the absolute value is isolate the absolute value. So step number 1 here would be to subtract the 2 over. So that leaves me with 4x, absolute value of 4x plus 1 over 3 equals 5. That's definitely stuff there. So then I could break this up into two cases. I always do the positive one first. That's just habit. But the absolute value of that stuff could equal +5, or what's inside the absolute value could equal -5. Now here, remember the way to get rid of the 3 in the denominator is to multiply both sides by 3 so that it cancels out here. That's going to leave me with 4x plus 1 equals -15. Subtract 1 from that, I get 4x equals -16. Divide by 4, x is equal to -4. Same thing here. Multiply by 3. Cancels it out here. So I have 4x plus 1 equals 15. Subtract the 1, that gives me 14. So x would be 14/4, or if you divide by 2, top and bottom by 2, you get 7/2. Right? Now, when you get more difficult equations, what you need to think about is these absolute values are kind of like parentheses. I would read this as 5 minus 3 times this equals 8. In other words, a very common mistake you're not thinking about this in terms of parentheses, is to turn the 5 minus 3 into a 2. That's not true. If you want, you could almost put sort of an invisible set of parentheses there to see that that 3 is really attached to this. So you can't subtract those two. But the strategy would be I want to isolate this absolute value. So first thing I'm going to do is subtract 5 minus 5. So then I end up with negative 3 times the absolute value of x plus 7 equals 8 minus 5 is 3. And then I'm going to divide by negative 3. Cancels there. And that leaves me with the absolute value of x plus 7 equals negative 1. Now, if you think about this, yes, I do have the absolute value of stuff equals a number, but is it possible for the absolute value of something to come out to be a negative? That's not going to happen, right? We could make a rule out of this. The absolute value of stuff has to be a positive or possibly 0. There's no way it could be negative. I guess we could say this. The absolute value of stuff equals a negative. Never, right? It's not going to happen. So right here, we don't need to break it up into cases. We just know that this can't be true, right? So we would just go straight to saying there's no solution. Okay. Now, what if we have both of these in absolute value? So I'm trying to solve something like this. The truth is you could work with either one, and this, if we treat it just the same way, do the same sort of algorithm, we could say that the absolute value of this stuff is going to equal this when it's positive, which is x plus 6. So we could have 5x minus 2 equals x plus 6. If both of these were positive, that's the equation we would have. But we also know we could look at it as if it was negative. So 5x minus 2, I'm going to put an or in between, could equal the negative of x plus 6 as well. Because if you think about it, if this was a negative times x plus 6, the absolute value would have made it positive x plus 6, right? So you're still breaking it up into the two cases. But it is important to put that negative on the whole thing on the right side. Okay, if you put absolute values of that, that's going to be the same as x plus 6. And then we can solve. So if I subtract x over here, add the 2 over here, I get 4x is equal to 8. X is equal to 2. I'm going to distribute over here. So 5x minus 2 equals negative x minus 6. Add the x over here, add the 2 over there. That's going to be negative 4, and that's going to give me negative 2/3. It is important that you'd want to check to make sure when you have absolute value equals not just a number, but some kind of an expression here, because sometimes you can get extraneous roots. Which if you recall, when we did radical equations, that happens sometimes. So just a quick check of this. I'm going to put 2 in for x here. That's going to be 5 times 2 is 10, minus 2 is 8. So I'm going to get the absolute value of 8. And if I put 2 into here, I get the absolute value of 2 plus 6, which is absolute value of 8. So that works as well. A little bit harder here to check this one. If I plug in negative 2/3 for x, let's just write it out. 5 times negative 2/3 minus 2, I want to see if the absolute value of that is equal to the absolute value of negative 2/3 plus 6. This is really negative 10/3. And if I want to subtract 2 from that, I'm going to want to multiply that 2 by 3 over 3 to give me negative 10/3 minus 6/3 is negative 16/3. And we're going to see here if that equals this. So I want to give 6, I want to multiply that one top and bottom by 3 over 3. And I end up with negative 2 plus 18, which is negative 16/3. So the absolute values of both sides would be equal to each other. So both of these answers actually work. Okay. Similar idea, but something unusual happens here. So if I work, and you could do this, I could do this with either one. I'm just going to work with the one on the left. Absolute value of stuff, so that means x plus 3 could either equal, when this is positive, x plus 8, or this x plus 3 could equal the negative of what's inside, negative x plus 8. Now look what happens here. If I have x plus 3 equals x plus 8, and I subtract x from both sides, I end up with 3 equals 8, which is, of course, not true. We've seen that before, so this means I don't get any solution there. But here, if I distribute, I could add the x over here, subtract the 3 over here. That's going to be negative 11. And that gives me x equals negative 11 halves. And we can do a quick check of that. Okay, I didn't make these easy, did I? Negative 11 halves plus 3, I want to see if that, when I take the absolute value of that, is equal to negative 11 halves plus 8. 3 multiply top and bottom by 2. Same thing over here for the 8. That's going to be a negative 11 plus 6 is negative 5 halves. Negative 11 plus 8 times 2 is 16 is also negative 5 halves. And so, yes, it does work. All right. Now let's get into inequalities, which we were doing in the previous class here, but now we're going to throw some absolute values with our inequalities. And for here, it's really helpful to think about a smaller situation like I did with an equation. Just absolute value of x less than or equal to 4. And I'm actually going to use a number line here. Just thinking about it, what numbers could I take the absolute value of and have it be less than 4? And if you think about it, 4 works, right? 4 is less than or equal to 4. I can't go plug in 5. That wouldn't work. But I can use 3, 2, 1, 0. I can even use negative numbers, right? Like negative 1, absolute value of that is less than 4. Negative 2, negative 3. Negative 4, the absolute value of that equals 4. But if I go to negative 5, the absolute value, that's going to be bigger than 4. So what I learned from this is if the absolute value of x is less than 4, what it means is x itself is between 4 and negative 4, which I can put in interval notation, right? That says the same thing as negative 4 and 4. But more importantly, what the takeaway from this is, what I learned from this is if I have the absolute value of some stuff, if it's more than just x, less than okay, again, it has to be a positive number, then what must be true is that the stuff inside, like the x, has to be between that positive number and the negative of that, right? The negative of the very same number. And that is going to be the way we can approach an absolute value if it's a less than or equal to, or even just less than. Now there's a slightly different well, very different situation when the absolute value of something is greater than a number. Greater, in this case, it's greater than or equal to. Let's do the same idea. Let's make a number line. And let's think about numbers that work. Certainly, let's start positive. Certainly 3 works because the absolute value of 3 is greater than or equal to 3. It's equal to 3. Now, what numbers also work? 4 would work, 5 would work, 6 would work. And so any number bigger than 3, clearly the absolute value of that will be bigger than 3. Now, if we think negative numbers, negative 3 works, but not negative 2, that would be less than 3. I have to go this direction, negative 4, negative 5. When I take the absolute values of those numbers, they're going to be greater than or equal to 3. So how would we describe these answers? This says x is less than or equal to negative 3, or x is greater than or equal to 3. Notice I can't put these numbers and these numbers together. I can't write it as a single inequality like I can with well, a single statement with two inequalities in it. I can only do that when it's less than. These have to be separate because we're talking about completely different numbers on the number line. And I know I can write that in interval notation, but the bigger idea is if I have the absolute value of stuff greater than, okay, say this works for greater than or equal to, it doesn't really matter. A number, again, I'll put the positive number. Then we have two situations. We could say that the stuff is less than or equal to the negative of that number, or the stuff is just greater than or equal to that number, that positive number. Okay, so it's kind of, you have to study this a little bit, and it's kind of, you have to know the difference whether you're dealing with a greater than or a less than. This is going to be our format for solving these. Okay. So, example here, there's my stuff. Absolute value of stuff is less than or equal to 7. And so, I mean, even without, that thing we just talked about, if I cover that up and think about what numbers would work, everything inside behind here would have to be a number between 7 and -7, right? Numbers between -7 and 7 are the only numbers that could be behind my thumb here and have the absolute value of that be less than 7. So then I pull it away, and now I know that 2x plus 1 has to be between -7 and 7. When you use less than signs, by the way, that one way to read that is to say this is between -7 and 7 if you have less than signs for both of these. And this is called a compound inequality. You can actually, there's really two inequalities there, right? One of them is this, and the other one is this, but you can usually solve it without breaking up into two pieces. If I subtract 1, I've got to subtract 1 from everybody here. -7 minus 1 is -8. 7 minus 1 is +6. And then if I divide by 2, I've got to divide everybody by 2. So -4 less than or equal to x less than or equal to 3. And if it helps, you could draw this out on a number line. You could say, okay, -4 to 3, if x is between these two, then we're talking about these numbers here. And so in interval notation, we would have bracket -4 to +3. Yeah, for the homework, we'll still use interval notation. Now this one is a greater than. And so in that situation, if I cover those up, think about the absolute value of stuff is bigger than 9. Let's do the positive case first. That means whatever is in there has to be greater than 9. Or if you think negative numbers, whatever's in there has to be less than -9. In both cases, I have 4x minus 3. All right, we'll just solve these individually. So I'm going to add 3 to this. 4x is less than -6. So x is less than -6/4, which I guess is 3/2. -3/2. Add the 3 here. 4x is greater than 12. Divide by 4, I get x is greater than 3. Again, if it helps, let's see, this time I'm not including it, so these would be open circles. Less than -3/2 is that way. Greater than 3 is this way. So in interval notation, we would write this as -infinity to -3/2, not including union 3, not including to infinity. Okay, let's take a look at these next two examples. Now, because we did one similar with an equation here, remember that, again, that -3 is attached to the absolute value. It's multiplied, so you can't simplify 10 minus 3 and make that 7. These are separate terms here. So what can I do is I can subtract the 10 first. I want to try to isolate that absolute value. -3 absolute value of 2x plus 5 is greater than 1 minus 10 is negative 9. And then divide by negative 3. And remember with inequalities, if I divide by a negative number, the inequality sign gets reversed. So this is now going to switch to a less than sign. Absolute value of 2x plus 5 is less than 3. So it is important to isolate the absolute value because you can see the problem started as a greater one, but it ended up, once we isolated, as a less than. And so you should know how to solve this. So you might want to pause the video and see if you can solve this like the previous example, like number 1. Absolute value of stuff less than 3 means 2x plus 5. I don't need 2 cases here, is between, just less than, between negative 3 and positive 3, because it's a less than. Subtract 5. Negative 8 is less than 2x is less than negative 2. And then I'll divide by 2. Negative 4 is less than x is less than negative 1. In interval notation, this would be the numbers between negative 4 and negative 1, not including. Okay, maybe try number 4. Good time to pause the video. Similar type of problem. All right. So yeah, again, that's not 5. Subtract the 9 first. Divide by negative 4. And sure enough, like the last one, what we have now, since we divided by a negative, the sign's going to have to change to a greater. Negative 8 over negative 4 is positive 2. And so the greater situation, this is the one where you have 2 cases. Absolute value of stuff is bigger than 2 means the stuff is greater than 2, or the stuff is less than the negative of 2. I guess we'll solve this one first. So you could subtract 3. Negative 2x is less than negative 5. And then divide by negative 2. But if I divide by negative 2, then I'm going to be changing the sign. So it's going to go back to greater than 5 halves. Over here, if I subtract the 3, I have negative 2x is greater than negative 1. And then if I divide by negative 2, sign switches, x is less than 1/2. Again, remember what I'm doing. I probably should show this as I'm dividing by negative 2. Over here, I did the same thing. Switch the sign. Yeah, it might be helpful for this one to actually write this out on a number line. So, because 1/2 is smaller than 5 halves. So here's 1/2, and this is saying x should be less than that. Should be going this way. 5 halves, if x is greater than that, goes this way. So here we have negative infinity to 1/2, not including, or 5 halves to infinity. Okay. A couple more here, but I want to do these quickly because I want you can't just be on autopilot here. You've got to watch out for some things. So something like this starts as a less than. We're going to subtract the 7 first. Negative 2, absolute value of x plus 5 less than or equal to 6. And we're going to divide by negative 2. It's just like the last problem, 2 problems. But we divided by negative 2, so that has to switch the sign. 6 over negative 2 is negative 3. This is what I mean by you can't be on autopilot. We have a sort of a recipe for how to deal when we have absolute value stuff is greater than 3. We've said it was greater than this or less than the negative of that. But if you stop for a second and think about this, What do we know about the absolute value of anything I plug in here is going to come out to be positive, right? Always. So no matter what you plug in for x, this is going to be a positive thing, and a positive thing is always greater than -3, right? In other words, this is true for all x, right? Any x value I plug in, that's going to be a true statement. So what is that telling me about the solution? The solution is any number for x will work, right? X can equal any number, but if we're writing this in interval notation, we would say that means our solution is any number between -infinity and +infinity. Now compare that with this one. This one's pretty easy. If I subtract the 5 over, I end up with the absolute value of 2x minus 9 is greater than or equal to, oh shoot, -5. How about, okay, let's change this. Let's suppose this was a minus here. This was a minus. There we go. That's not what I wanted. Oh, and let's say this was a minus. I'm going to adapt on the fly here. So if I added the 5 over, this would have been 5. But then if I divide by a -1, what I end up with is the absolute value of 2x minus 5. I've got to switch the sign, is less than or equal to -5 after I adapted it. So now think about it. We could go through an algorithm here, but take a moment to think about this. We know that this is always, anytime you isolate an absolute value, that's always going to come out to be positive. And what is a positive number always less than -5? Yes, right? So I'm sorry, never. Positive number is never less than -5. Sorry. This is never true. Never true. So this isn't going to work no matter what I plug in for x. This is not going to be true, right? This is never going to be true. So if it's never true, then what should I say for this? I should say there is no solution. Okay. And I suppose for both of the examples, you could sort of generalize here that if you get it down to the absolute value of stuff is greater than or even greater than or equal to a negative number, that's going to be -infinity to infinity, right? It'll always be true. But if you end up with absolute value of stuff is less than or equal to a negative number, that's always going to be no solution. So watch out for that. Last thing on absolute values, these are not equations. This is more about just simplifying things without absolute values. Here we have an expression, 3 minus the square root of 10, absolute value of that plus 3. So here's what I mean by that. Whenever you have, let's review, whenever I have the absolute value and what's inside is positive, we can just remove the absolute value, right? For example, the absolute value of 7 is 7. But if what's inside is negative, what do we get? If we get a positive, but it's really the negative of this number, right? It's going to be the negative of that negative number. And the example here is if I have the absolute value of -7, yes, I know it's 7, but how do you get 7? It's the negative of -7, right? That's 7. So this is the big idea I want you to think about when you're simplifying these absolute values expressions. Anytime you want to remove an absolute value, that's what it's asking us to do. You have to first make a decision. I need to know whether this 3 minus root 10 is positive or negative. And I claim you should be able to do this without a calculator. You should know that since root 9 is exactly equal to 3, that root 10 is a little bit bigger than 3, right? It's probably like 3.1 or something like that. So if I go 3 minus something bigger than 3, this part is going to be negative. And so if I have the absolute value of something inside that is already negative, if I want to simplify it, it's going to be the negative of what's inside. 3 minus root 10, and then this plus this 3. And if I distribute this, we see that the negative 3 and the positive 3 actually cancel out. And so this expression, absolute value of 3 minus root 10 plus 3, is really just equal to root 10. Now, if I had, okay, let's do, maybe I can squeeze one more example in. If I had like, let's say I had like a 4 minus the square root of 3, and I said simplify that without an absolute value. Let's just, I need to know whether this is positive or negative. But root 3, like root 1 is 1, right? Root 4 is 2. So root 3 is somewhere in here, right? It's some number between 1 and 2. It's 1 point something, right? You don't have to know exactly to know that 4 minus 1 point something is going to make the inside positive. 4 minus root 3 is a positive number, in which case there's no reason to have an absolute value. I can just remove the absolute value. This is just equal to 4 minus root 3. See the difference? All right, so last bit with this idea. Now I have an expression that doesn't have just numbers. I have the absolute value of x plus 8 plus the absolute value of x minus 5. But I'm told that x is a number between negative 8 and 5. And so as we've seen, I need to, before I remove an absolute value, I need to decide if what's inside is positive or negative. I'm going to put this for both of them. Positive or negative. Now, how would I decide that? You can literally do this. If we're told that x is a number between negative 8 and 5, you can literally just think of a number that's between negative 8 and 5. There's plenty. Negative 7, negative 2, 4, 3. I know what I would choose. I would choose 0. And if you put 0 in for both of these, 0 plus 8 is a positive number, and it should be true not only for 0, but any number you plug in there. But if I do 0 minus 5, this part becomes negative. So when I simplify this, since this inside's already positive, I can just remove the absolute value. Since this is negative, I can remove the absolute value, but I have to add a negative, right? It's the negative of the negative. So now I've gotten rid of the absolute values. Now we'll just clean this up a little bit. That's x plus 8. If I distribute this, minus x plus 5, x's cancel, and this gives me an answer of 13. So what that's literally saying is if you use any number between negative 8 and 5 and plug it in here, you will always get 13. You should try it yourself. For example, if I let x be 2, what do I get here? I get the absolute value of 10 plus the absolute value of 2 minus 5 is negative 3. I get 13. If x is negative 1, I get negative 1 plus 8 is the absolute value of 7. Negative 1 minus 6 is minus 5 is the absolute value of negative 6, and that adds up to 13 as well. Okay. Oh yeah, and just to see like maybe something different, what if we were told x was less than negative 8? So you can use any number you want, less than negative 8. Let's try negative 10. X is negative 10. I can tell here negative 10 plus 8 will give me a negative number. Negative 10 minus 5 is also a negative. So in this situation, I would be removing the absolute values and putting a negative on both of them. And if I distribute negative x minus 8 plus negative x plus 5 gives me negative 2x minus 8 plus 5 is minus 3. And that's the best I can do. This expression would simplify to this if x was a number less than negative 8. So maybe pause the video, last example here. See if you can, these are related to each other. Simplify this fraction if x was first a number greater than 4 and if second if x was a number less than 4. Okay, if x is greater than 4, I could use 5, 6, 7, it doesn't matter, I'll use 7, I could use 100. If I put that in here, this is going to be positive, 7 minus 4. So I literally can just remove the absolute value, and x minus 4 over x minus 4 is 1, right? So what this says, if you use any number bigger than 4 and plug it in, you'll always get 1 here. Whereas if x is less than 4, so let's say I choose 1 minus 4 here is a negative number. So when I remove the absolute value, I have to add a negative. But then negative of x minus 4 divided by x minus 4, I'm just going to add parentheses. Those would divide out, but that leaves me with negative 1. All right. Hopefully this helps with absolute values. Let me know if you have any questions. Thanks.